December 19th, 2025. Just 10 days away. Something is racing toward the inner solar system at over 60 kilometers per second. It's massive. 1,000,000 times larger than Oumuamua, the strange interstellar object discovered in 2017. NASA calls it a comet. But a Harvard professor says the odds of it being natural are 1 in a trillion. So who's right? And why does December 19th matter so much? This object, called 3I/Atlas, is unlike anything we've seen. It's glowing green one week, blue the next. It has a twisted tail, a unique shape, and jets that defy the typical behavior of comets. It's coming closer every day. And some people believe it's not just passing by, but watching us. There are two sides to this story. One says it's an incredible natural wonder from another star system. The other? A potential alien probe disguised as a comet. Real science. Real data. But very different conclusions. You've seen the headlines. Now it's time to go deeper. 10 days left. Let's figure out what 3I/Atlas really is, together. To understand why 3I/Atlas has the scientific world holding its breath, we have to go back almost 50 years. August 15, 1977. A radio telescope in Ohio detected something unexpected. A strange burst of energy is coming from deep space, right in the direction of the Sagittarius constellation. It lasted 72 seconds. The frequency? 1420 MHz, the same wavelength emitted by hydrogen, the most abundant element in the universe. Astronomers called it the "wow" signal, named after the handwritten note one scientist scribbled in the margins. Wow! It was the perfect frequency, the perfect length, and it never happened again. Some believed it was a message. Others said it was just noise. But now, almost 5 decades later, a new object is approaching our solar system, from nearly the same part of the sky, only 9 degrees apart from where the signal came from. Coincidence? Maybe. Maybe not. Fast forward to July 1st, 2025. That's when scientists first spotted 3I/Atlas. At first, it looked like a distant comet. But then, things got weird. It was massive. Way too big for a normal comet. Its tail structure didn't match anything astronomers had seen before. And it was glowing. Not just white or yellow, but shifting colors, blue one week, green the next. Images from NASA's Mars Reconnaissance Orbiter confirmed it. This thing wasn't just strange. It was downright bizarre. And here's where it gets even more interesting. 3I/Atlas is not drifting randomly. It's on a path that brings it straight through the inner solar system. Past Mars. Toward Earth. Its closest approach? December 19th. Just days from now. Could it be a relic from another star system? Or is it something more, deliberate? This isn't just a story about a rock in space. This might be the beginning of something much, much bigger. And this is just the beginning. Let's talk about the man behind the theory that's shaking up the scientific community. His name is Avi Loeb, a Harvard astrophysicist, former head of Harvard's Department of Astronomy, author of over 1,000 scientific papers, and a New York Times best-selling book. He's respected, brilliant, and controversial. Back in 2017, when the interstellar object Oumuamua passed through our solar system, it made headlines by suggesting it might be artificial, possibly a probe from another civilization. That idea was dismissed by many. But Loeb stood his ground. His message was simple. Science needs to stay open-minded. And now, with 3I/Atlas, he's saying something even bolder. He believes the anomalies we're seeing don't just suggest something strange, but something designed. Let's look at why. 6 major anomalies. Each one strange on its own. But together? Nearly impossible to ignore. Anomaly number 1, the orbit. 3I/Atlas is on a retrograde orbit, meaning it's moving opposite the direction of most planets. That's rare, but not unheard of. What makes it strange is that, despite moving the wrong way, it's still aligned very closely to the plane of the solar system, just 5 degrees off. Picture a bicycle riding against traffic, but somehow staying perfectly in the bike lane. Loeb ran the numbers. The probability of a retrograde object also being that well aligned? Around 2%. Anomaly number 2, the Jupiter coincidence. Its closest approach to the Sun, called the perihelion, just happens to align with the exact boundary of Jupiter's Hill sphere. That's the zone where Jupiter's gravity dominates. How close is it? Down to the 5th decimal place. Less than 1/10,000th of an astronomical unit off. In the 1960s, Carl Sagan once proposed that a spacecraft trying to use the solar system for gravitational assists would enter through this exact region. And now 3I/Atlas is doing just that. If you were designing a trajectory to scan our solar system, this is exactly the route you'd take. Anomaly number 3, the Grand Tour. This object isn't just swinging by randomly. It passed near Venus, then Mars, then Jupiter. 3 major planets, lined up like targets in a survey mission. NASA hasn't commented on this route in any of its briefings. But simulations show it's one of the most efficient ways to gather data on the inner planets while using minimal fuel. It's almost like someone plotted the course ahead of time. Anomaly number 4, the anti-tail. Most comets have a tail that streams behind them, pushed by solar wind. But 3I/Atlas has something else. A structure pointing in the opposite direction, toward the Sun. When processed at different viewing angles, this anti-tail appears as a sharp, needle-like jet. Not drifting, not chaotic, but organized. Some have compared it to early concepts for microparticle defense systems, like lasers designed to clear debris from a spacecraft's path. That might sound like science fiction, but NASA's been researching similar ideas for decades. Anomaly number 5, the nickel surface. Spectroscopic analysis hints that the object contains unusually high amounts of nickel compared to iron. That combination, nickel-rich alloys, doesn't match what we typically see in natural comets. But it does resemble industrial materials used in spacecraft shielding and high-stress structural components. No one's saying this is proof, but it's definitely strange. Anomaly number 6, the solar blind spot. Here's something clever. 3I/Atlas reaches its closest point to the Sun, its perihelion, right as it moves behind the Sun from Earth's perspective. That's important, because during that time, we can't see it. Radio telescopes, optical sensors, they're all blinded by the Sun's glare. It's the perfect time for a maneuver, like slowing down using the Sun's gravity. A trick known as a reverse Oberth effect. If you were trying to adjust your trajectory without being seen, this is when you do it. 6 anomalies. 1 in 1,000. 1 in 10,000. 1 in a billion. By the time they're all combined, Loeb says the odds of all this happening naturally are less than 1 in a trillion. Now let's return to the wow signal for a moment, because here's where things get even weirder. That 72-second signal from 1977? It came from almost the exact direction that 3I/Atlas is now coming from. The angular separation between the two? Just 9 degrees. Close enough to raise eyebrows. Some researchers have tried to dismiss the connection, but Loeb dug deeper. He looked at the approach velocity of 3I/Atlas. The Doppler shift from its movement, about 10 kilometers per second, matches the frequency offset of the wow signal. And based on the energy needed to send a signal like that across the galaxy, the source would have needed about half a gigawatt. That's the same as a small nuclear reactor. Is that just another coincidence? Maybe. But here's the thing. No one actually checked if 3I/Atlas was emitting any radio signals, until now. The deeper we look, the stranger it gets. And remember, this is just one side of the story. Next, we'll hear from the scientists who believe 3I/Atlas is still, at its core, just a comet. But even they admit, it's a comet unlike any we've ever seen. Not everyone is convinced by the alien hypothesis. In fact, most planetary scientists think the answer is a lot simpler, and a lot more grounded in reality. One of the most vocal critics is Dr. Jason Wright from Penn State's Center for Exoplanets and Habitable Worlds. His main point? The logic behind Loeb's theory is flawed. It's something called the post hoc probability fallacy. In simple terms, it means calculating the odds after you already know the outcome. Like walking onto your balcony, seeing a car parked below, and thinking, what are the chances that this specific car would be parked right here at this exact time? The answer? Pretty high, if you consider how many cars and balconies exist. According to Dr. Wright, that's exactly what's happening with 3I/Atlas. One anomaly after another is being cherry-picked to fit a narrative. But in science, coincidence doesn't always mean conspiracy. And the scientific consensus? NASA said it clearly. It's a comet. Case closed. The Hubble Space Telescope confirmed it. It has a coma, a glowing cloud of gas and dust. It has a tail, created by solar radiation pushing particles away. It's outgassing water vapor, carbon dioxide, and carbon monoxide. In every measurable way, it's acting like a comet. Now let's walk through those so-called impossible anomalies and see what natural explanations actually exist. First, the orbit. Yes, it's retrograde. Yes, it's aligned within 5 degrees of the ecliptic. But that's not unheard of. In fact, among the small number of interstellar objects we've detected so far, just 3 total, including Oumuamua, there's already a wide range of orbits. When the sample size is that small, outliers are expected. So is 5 degrees unusual? Maybe, but not miraculous. Next, the nickel. Loeb's team noted a higher than usual nickel-to-iron ratio. But here's the thing, 3I/Atlas didn't come from our solar system. It may have formed around a completely different star, with a different chemical profile. And when you're dealing with something billions of kilometers from home, that kind of chemical difference isn't just possible, it's expected. Also, when an object is still far from the sun, its outer layers can reflect strange ratios. As it gets closer, those readings tend to normalize. It's too early to conclude. What about the anti-tail? That strange forward-pointing feature? It looks odd, yes. But it's not unique. Astronomers have known about anti-tails since the 1970s. A scientist named Zdenek Sekanina published a paper on them back in 1974. And we've seen similar features on other comets, like 17P/Holmes and C/1961 R1. It's not common. But it's not evidence of alien tech either. Then there's the timing. The claim is that 3I/Atlas passes perfectly near Jupiter, Venus, and Mars, as if it's conducting a survey mission. But here's the truth. Any object that enters the inner solar system along the ecliptic plane is likely to pass near some planets. It's a crowded zone. And when near isn't clearly defined, it's easy to make almost any path look intentional. As Dr. Wright points out, if it passed farther away, someone would still call that suspicious. Close is a pattern. Far is avoidance. Everything becomes anomalous if you want it to be. Now, the big one, the wow signal. 9 degrees apart. Matching blue shift. Same general direction. It sounds compelling, until you understand how big 9 degrees really is in astronomy. That's 18 times the size of the full moon in the night sky. Also, recent research from 2024 linked the wow signal to a natural source, a hydrogen cloud associated with a known comet. Multiple peer-reviewed papers have supported this explanation. Today, most astronomers don't believe the wow the signal was alien at all. And that brings us to the simplest point of all. 3I/Atlas is acting like a comet. It's glowing brighter as it approaches the sun. It's ejecting gas and dust. It's following a predictable arc based on solar gravity. It walks like a comet. It quacks like a comet. You know how the saying goes. There's even a popular phrase among astronomers. Comets have tails, and they do exactly what they want. They're messy, unpredictable, and full of surprises. But they're still natural. Finally, let's talk about Avi Loeb himself. Back in 2017, he made headlines with his theory that Oumuamua was artificial. But that object never showed a tail or any signs of outgassing, so the idea stuck around. 3I/Atlas is the opposite. It is outgassing. It does have a tail. And it behaves like, well, a giant, overachieving comet. And yet, Loeb is still pushing the alien angle. So far, none of his claims about 3I/Atlas have been peer-reviewed or accepted by leading journals. And within the planetary science community, the level of agreement with his theory? Basically 0%. As one scientist bluntly put it, "Science is not marketing. Curiosity is good. Asking big questions is great. But jumping to extraordinary conclusions without extraordinary evidence, that's not science. That's speculation." And for most researchers, the answer to the 3I/Atlas mystery is already clear. It's an incredible object. A rare visitor. A beautiful comet from another star. But it's not a spaceship. Still, something doesn't sit quite right. Not because the science is wrong, but because there are things we don't yet understand. And that's where this story takes its next turn. Because even if 3I/Atlas is natural, the questions it's raising are far bigger than one object in the sky. So where does that leave us? Is 3I/Atlas a comet, or a probe? A mystery, or a misunderstanding? Here's the truth. Both sides have valid points. Let's start with Avi Loeb. He's right about one thing, maybe more than one. First, science should always stay open to the possibility of alien life. The universe is massive. We've only just begun to explore it. Dismissing the idea outright doesn't help anyone. Second, some of the features of 3I/Atlas are genuinely unusual. The anti-tail, the orbit, the timing. They deserve closer study, not instant dismissal. Third, Loeb is also right about this. We need to collect more data. Radio signals, spectroscopy, deep scans. If we don't look, we'll never know. And lastly, he makes a strong case that SETI, the search for extraterrestrial intelligence, shouldn't just focus on distant stars. We should also be paying attention to what's moving through our own solar system. But that's where the agreement starts to fade. Because, for all his bold claims, Loeb's math is deeply flawed. The probabilities he uses are based on assumptions made after the fact. That's not how science works. It's like building a puzzle using only the pieces that fit your story and ignoring the rest. He also tends to dismiss natural explanations too quickly, even when they're backed by data from telescopes like Hubble or peer-reviewed studies from planetary scientists. And perhaps most frustrating of all, he leans heavily on speculation while waving away criticism by saying, "I'm just asking questions." In science, asking questions is vital. But answers have to be rooted in evidence, not excitement. Now let's look at the other side, the planetary scientists. They're right about a lot too. They've studied hundreds of comets. They've seen strange behavior before. And based on current data, 3I/Atlas fits the definition of a natural object. They also understand that interstellar objects are expected to be weird. After all, they're from other star systems, with different chemistries, different origins, different paths through the galaxy. And let's not forget, we've only seen 3 of them so far. That's not enough to declare what's normal and what's not. So what's really going on here? Here's one possible answer. 3I/Atlas is a stunning natural wonder from beyond our solar system. It was likely formed around a different kind of star, in a different kind of environment. Over billions of years, it drifted through space, shaped by unknown forces and cosmic collisions. By the time it entered our neighborhood, it had already evolved into something rare, something unique. It's moving fast, changing color, ejecting jets of gas, and doing it all in a way that breaks the rules we're used to. But that's not because it's artificial. It's because every comet is different. There's an old saying in astronomy. Comets are like cats. They have tails, and they do whatever they want. 3I/Atlas might be the most photogenic, unpredictable, and bizarre comet we've ever seen. But it's still a comet. And now, we arrive at the real controversy. Because at the end of the day, this story isn't really about aliens. It's about something deeper. How should science be communicated? How do we balance wonder and reason? Curiosity and caution? Open-mindedness and evidence? In today's world, extreme claims travel fast. Media headlines love mystery. Social media rewards viral theories more than verified ones. And when someone like Avi Loeb makes a bold statement, it spreads far faster than the slow, careful explanations of traditional scientists. That's not just a problem for 3i/Atlas. It's a challenge for all of science. We need room to imagine, without abandoning the rigor that makes discovery real. We need scientists who ask wild questions, and others who demand solid answers. And most of all, we need an audience, us, that's willing to hear both sides and think for ourselves. Because whether 3i/Atlas turns out to be a comet, a probe, or something entirely new, it's already forced us to look harder, think deeper, and question the limits of what we know. And maybe that's the most important discovery of all. And now, we wait. December 19th, 2025. The day 3i/Atlas makes its closest approach to Earth, just 1.8 astronomical units away. Roughly 270 million kilometers. It's not close enough to threaten us, but it is close enough for the most advanced instruments on Earth, and in space, to take a good, long look. So what are we expecting? Several key data sets are scheduled to be released around that date. First, spectroscopic measurements from ESA and NASA will tell us exactly what 3i/Atlas is made of, right down to the molecular level. Second, scientists are analyzing the jets of gas and dust shooting from its surface. If they contain mostly water, carbon dioxide, and carbon monoxide, that points to a typical comet. But if they include exotic compounds, that changes everything. Third, researchers will study non-gravitational acceleration, tiny movements not explained by gravity alone. Many comets exhibit these, but if 3i/Atlas shows consistent thrust without clear outgassing, that would be hard to explain. And finally, radio observations are already underway. We're listening, across a wide range of frequencies, to see if this object is saying anything at all. So what are the possible outcomes? Let's break it down. Scenario A, the natural comet. This is the most likely outcome, about 95%. Spectroscopy confirms a typical cometary composition. The jets behave exactly as expected. The radio signals? Silent. Or just background noise from space. In this case, science wins. Not because it proves anything extraordinary, but because it confirms what we know, and what we're learning. Even then, 3i/Atlas will still be one of the most fascinating comets ever observed. Scenario B, the anomaly. This is the edge case, about 4.9%. Imagine this. The composition doesn't match any known comet. The elements are strange. The acceleration doesn't line up. The structure is too stable, too consistent, too engineered. No radio signals. No clear signs of intelligence. But the object refuses to fit any known model. It's not an alien probe, but it might be something that forces us to rewrite our understanding of how comets form and evolve. A moment of scientific revolution. Scenario C, the 1 in 1,000 dream. Loeb's dream. The long shot. 0.1%. A structured signal is detected. At 1420 MHz, the same frequency as the wow signal. Repeating patterns. Encoded information. Intelligence. And in that moment, everything changes. But whether that moment comes or not, one thing is already clear. 3i/Atlas has inspired millions. It has sparked global conversations. Reignited interest in SETI, not just among distant stars, but right here, within our own solar system. It has reminded us that science isn't a fixed set of facts, it's a process. A journey. A constantly evolving search for truth. And sometimes, that journey matters more than the conclusion. Because the real discovery is what we're learning about ourselves along the way. Now it's your turn. We've seen the data. We've heard both sides. We've explored the strange and the skeptical. So what do you think? Is 3i/Atlas just a fascinating natural comet? If that's your take, tell us why in the comments. Or do you think this could actually be something artificial? A probe, maybe, sent by someone or something out there. What convinced you? Was it the orbit? The timing? The anti-tail? Or maybe you're like many of us, still waiting for the data before you decide. And honestly, That might be the smartest choice of all. Let's see where everyone stands. Drop your vote in the comments. And while you're at it, tell us where you're watching from. This is a global moment. People all over the world are following this story, from observatories and classrooms to bedrooms and backyards. So wherever you are, type it out. City, country, we'll light up the map together. Because on December 19th, when NASA releases its findings, we'll all be watching together. Think of it like a watch party. A science countdown. One world, one moment. And if you're wondering what to do between now and then, here are a few suggestions. First, follow the official updates. NASA's Solar System page and ESA's comet tracking feed will be sharing the latest observations as they come in. Second, read both sides. Avi Loeb's papers are easy to find. But don't stop there. Also look at the critiques from planetary scientists. Compare them. Question them. That's what real science is about. Third, think critically. Claims about aliens are exciting, but extraordinary claims require extraordinary evidence. Always. And if this story has sparked something in you, if it's made you curious, made you wonder, don't keep it to yourself. Share this video with 3 people who'd love to explore the unknown with you. Friends who believe in science. Friends who believe in mystery. Friends who want to believe, but still want proof. And one more thing, this video is just the beginning. In our next episode, we'll dive into a question that no one really wants to answer out loud. What if it really is aliens? What happens next? Who speaks for Earth? Are there protocols? Government plans? Contingencies for contact? Would the public even be told? And if the answer is yes, how do you prepare? That's where we're going next. So stay tuned. Subscribe if you haven't. Turn on notifications. Whether it's a comet, a probe, or something in between, 3i/Atlas has already changed the conversation. Now it's up to us to keep it going. Together. So what is 3i/Atlas? A comet? A probe? A mystery wrapped in light? Maybe we'll find out on December 19th. Or maybe, not just yet. But here's what really matters. Whatever it is, 3i/Atlas reminds us of something bigger. It reminds us that the universe is far more vast, far more complex, and far more beautiful than we often stop to consider. It reminds us that science is still our most powerful tool for exploring the universe, when it's driven by curiosity, guided by evidence, and open to wonder. It reminds us that we need both skepticism and imagination, reason and mystery, analysis and awe. And sometimes, it reminds us that all we can do is wait. Just a few more days. Because no matter what the data shows, this object has already done something remarkable. It has pulled us together, across continents, across beliefs, across backgrounds, with one simple question. What if? And in that moment of asking, something truly human is born. As Carl Sagan once said, extraordinary claims require extraordinary evidence. But absence of evidence is not evidence of absence. So as we count down the final days to closest approach, stay curious, stay skeptical, stay human. And if you haven't yet, subscribe so you don't miss the reveal on December 19th. Hit like if you believe science will lead us to the truth, whatever that truth may be. And drop your answer in the comments. Are you Team Natural Comet or Team Alien Probe? Because no matter what we discover, the universe just got more interesting. We'll see you in the next episode. Just one quick note before we go. The voice you heard in this video? It's AI. It's not really Avi Loeb. Because let's be honest, if it were him, he probably wouldn't have included all those counterarguments. NASA, if anyone from your team is watching, we'd love official permission to use more of your footage in our next video. And aliens, if you happen to be watching, please leave a comment. We'd really appreciate it. See you next time.